Thank you for joining us at Valley Vision's webinar about the Zero-Emission Locomotive project. We're excited to share more information with you all about it and answer any questions you may have. My name is Grace Kaufman, and I'll be facilitating this webinar. So some logistics, so due to the large number of attendees that we have, everyone will be muted upon entry. But if you'd like to ask a question during the webinar, we have a Q&A box there where you can ask a question. One of our panelists will answer that for you all. And the webinar will be recorded. I know that's everyone's #1 question, so it will be recorded and it'll be on both Valley Vision's YouTube as well as our website. And as I said, please use the Q&A function to ask any questions that you may have during the webinar. If we aren't able to get to all of them, we will answer that in the follow-up email. And our agenda here today, so starting off with some welcome and webinar logistics, and then I'll pass it over to Bart from GTI Energy, who will introduce the project and the project team. And then I will hand it over to Ken at Sierra Northern Railroad, who will provide a history of locomotives and Sierra Northern Railway's local operations. And from there, I will go to Jennifer Hamilton, who will talk about hydrogen safety and technology from the Hydrogen Fuel Cell Partnership. And after that, we will go to George from University of California, Riverside, who will talk about operations, life cycle, and data. And finally, we will end with Valley Vision, who will talk about the public health improvements and impacts, and we'll end with audience Q&A. So thank you all again for joining us, and I'd like to hand it off to Bart.
Thank you, Grace. Good morning, all. Good afternoon. I think we have folks coast to coast, and I think we even had some registrants from Europe and Australia. So if you're here with us, thank you for joining us at weird times. If not, enjoy the recording. Happy to be here. Excited to talk about our project here. My name is Bart Silva, and I am a Research and Development Manager at GTI Energy. I focus on mobility or transportation topics. And I'll just briefly introduce the team, the project, and hand it off to the experts. Next slide, please. Thank you. So this project was funded by the California Energy Commission through H2RAM solicitation, which is short for hydrogen in rail and marine applications at ports. That was issued in 2020. And this solicitation offered, I think it was over $6 million that was awarded to 4 projects in 2021. The project and the funding, the source of the funding is provided from the Gas Research and Development Program, which comes out of the natural gas bills. It's a surcharge to the natural gas bills. And the intent is to develop science and technology that benefits California citizens that are not addressed by competitive or regulated entities. We're very excited to be part of this project and receive the funding. Really appreciative. We also have additional co-funders that provided money helping us do all of this work. So SoCal Gas and Sacramento Metropolitan Air Quality Management District have provided funding, helping with the project, as well as our project partners. Most of the project partners have are contributing to the project in form of in-kind contributions. The goal of this solicitation and of this effort, and also the goal of this technology development, is really to improve the air quality and reduce the burden on the disadvantaged communities that are disproportionately affected by a lot of the heavy duty and cargo handling operations. Technically, this specific solicitation and project was focusing on hard to decarbonize applications, such as, again, rail, marine. Cargo handling is also considered one of those, and they're difficult. They're hard, and that's why we're doing it. We're excited to be one of the first, if not the first, to approach that, and looking forward to taking it through completion. As I said, the project was awarded in 2021. We expect to wrap it up in 2025. We have a strong team of experts and partners. You can see we have Sierra Northern Railway that will be building and operating the locomotive and testing the locomotive. Frontier Energy that will be assisting with hydrogen safety and training aspects. UC Riverside that will be collecting and analyzing data and life cycle analysis. Valley Vision that's coordinating all of the communication and outreach efforts. Then we have our technology partners. So Ballard providing fuel cells, rail power tech providing software controls and electrical system integrations, OptiFuel providing mechanical system and subsystem integrations, including energy storage, and Velocity Strategies, who is the fearless project manager here, and Michael Faust representing Velocity Strategies. Just a quick introduction to GTI, so everybody knows why we're here and what we're doing here. So GTI Energy is a research and training organization focused on developing, scaling, and deploying energy transition solutions. We leverage the expertise of our scientists, engineers, and partners, collaborations like this that deliver innovations needed for low carbon, low cost energy systems. We've been doing this since 1941, working across the whole energy value chain. And our mission is to make the energy systems safer, cleaner, more efficient, and more affordable. And I think we all want our energy to be just that: cheap, clean, and safe. We are a nonprofit. We're independent. We don't sell or make anything, and that allows us to be technology agnostic and objective. Next slide, please. One of the reasons why we were excited in this project and we felt it was a place for us to participate and lead the team was the aspect of hydrogen. And just so happens that we've been working with hydrogen since probably 60s. Here you can see some publications our teams have published in the 70s, introducing the concept of energy carrier, or hydrogen being the energy carrier and foundation of economy revolving around hydrogen. So it is not a new idea. It's been on and off over the decades. We feel that the last few years are different. It's the interest in hydrogen, the disruption in the energy industry, the development, the pace of technology development, and the investment we see is unprecedented. So we are hopeful, we're confident that the hydrogen is here to stay, and this project will demonstrate how we can put it to work and improve the quality of life of the communities that are affected by the current diesel usage and the emissions, as well as noise and discomfort. Next slide, please. We at GTI Energy, I specifically work on transportation topics, and we have quite a bit of experience deploying and demonstrating technologies like this. So here you see our locomotive that we expect to put on the tracks sometime next year. But we have worked with Class 8 trucks and drayage operations at the port, with terminal tractors at the port, with hydrogen drones. So we have some firsthand experience with the problems that these emerging technologies see, and what the operators have to anticipate when putting it into operation. Next slide, please. That's about as much time as I want to take from the team. And thank you again for joining us. I will be happy to answer questions at the end of the webinar, and I'll hand it back to Grace. Thank you.
Thank you, Bart. Really appreciate that overview. And now I would like to turn it over to Ken Beard, who's the President and CEO of Sierra Northern Railway.
Thank you, Grace. Good morning. As Grace says, my name is Ken Beard, and I'm the President and CEO of Sierra Northern Railway. We're a freight operating railroad throughout California, both Northern California and Southern California. We are the lead on this construction and testing and operation of the zero-emission switching locomotive. So a couple things to define first. We are a Class 3 switching railroad. There are 3 levels of railroads in the United States in freight, the Class 1, Class 2, and Class 3. Most people are familiar with the Class 1 railroads. Those are the big guys, the BNSF, the UP, the KCS, the folks that haul the cargo across the country. Class 2s are regional railroads, medium-sized. And then the Class 3s are the most abundant railroads in the United States, with well over 500 Class 3 railroads in the States. But we're the smallest. As you can see from the slide, it's all based on revenue, not on actual size length. But just like our Class 1 partners, we do the same thing. We handle the freight. We handle the same box cars, same tank cars, and do the same work. We just don't haul it over the 1,000 miles across the country. We are also known as short line railroads. So within this state of California, given any year, there's 20 to 25 different short lines operating in the state. A lot of the short lines are Class 1 spinoffs, meaning that at one point in time, the Class 1 railroads, the big guys, they were operating these railroads, found them not to be cost effective to operate anymore, and they spun it off to smaller operators, and that's what developed the Class 3 railroads across the country. When we talk about switcher locomotives, and that's what this project is, it's a smaller locomotive. The Class 1 line haul railroads, they're 6,000 horsepower. They're big monstrosities of locomotives. They're made to handle large trains at high speeds across the distance. Switcher locomotives are a lot smaller, a lot lighter, and typically stay in a pretty confined area to switch industries, to switch yards and that type of stuff. In our case, we're building a unit that's about 275,000 pounds versus almost a 500,000 pound Class 1 line haul locomotive. Next slide, please. So, as I mentioned, we are a freight operating railroad. The Sierra line has operated in California since 1897. That would be our Oakdale line that operates up to the Gold Country. Short lines are considered to be the first mile / last mile of freight hauling. So again, we don't haul across the country, but we're the ones that serve the direct customers. We're the ones switching the cars in and out of the transload facilities, the warehouses, the yards. We at Sierra work in conjunction with 2 Class 1 partners, and that's the BNSF and the UP. I operate 3 railroads right now, one in the Port of West Sacramento, one in Oakdale, and one in Southern California. Between those 3, we have over 41 switcher locomotives in our fleet. They're currently a combination of older technology, EMD type units, as well as gensets. And now we're starting on this new hydrogen hybrid fuel cell locomotive. The name Sierra Northern was a combination of joining the Sierra Railroad Company and the Yellow Short Line in 2003. So while Sierra Northern Railway The name's only been around since 2003. The Sierra name has been around since 1897. We operate 160 miles of track, well over 160, through the prime industrial and agricultural areas through Central California. And just if anybody's looking us up, our alphanumeric code is SERA for Sierra Railroad. Next slide, please. This operation, where we will be building and testing this hydrogen locomotive, is at our West Sacramento operation, mainly serving the Port of West Sacramento. We cover throughout a good majority of the city. As you can see in this map, there's a star right in the middle, right next to the port. That's where our locomotive facility is. That's where we're building this locomotive. And then all of these blue tracks that go throughout the port, that is our test area. We have several customers in this area that we'll be testing the locomotive on and putting it through its paces. I think that's it for my part of this. My contact information is here, as well as my project partner, Michael Faust. And like Bart, I will be here through the webinar and be able to answer questions at the end. So thank you for your time and appreciate you attending.
Thank you, Ken. Appreciate that overview, and hopefully everyone is finding this as informative as I am. So now I'd like to turn it over to the Hydrogen Fuel Cell Partnership. Jennifer Hamilton, yeah, if you want to go ahead and start.
Great, thank you, Grace, and greetings, everybody. As Grace said, my name is Jennifer Hamilton. I'm currently the Technical Director at the Hydrogen Fuel Cell Partnership. For those of you who don't know us or haven't heard, we have recently changed our name from the California Fuel Cell Partnership, whom you may have heard of before, and we have been managed by Frontier Energy, so that's the connection there. So next slide. Just to give you an idea of who we are a public-private partnership that is concentrating on hydrogen and fuel cells in transportation. Historically, we've concentrated on light duty, but reaching out to heavy duty and other applications, as well as expanding our reach beyond the borders of California, of course, still concentrating on California because we're not quite done here. But we also have government members, and this has been something that's been unique to our organization. So we have a platform where industry and government can have some great conversations and interactions. So that's been a unique aspect of our organization. Next slide. So let me talk a little bit about hydrogen in California. I did realize I was remiss in not putting in our by the numbers slide, but just as a overarching theme, that overall energy and transportation systems are transitioning globally. We really are in an energy transition. Next slide. And hydrogen plays an important role in this across many, many sectors, and of course, transportation is a key one. So this image comes from the Hydrogen Council, which is a worldwide council that's put out some great publications. But you can see, the applications for hydrogen are broad and wide, and of course, even in the transportation sector, there are many, including the one we're talking about today. Next slide. In California, hydrogen fuel cell passenger vehicles are available. People are driving. I do drive a Toyota Mirai myself. So the vehicles across the top are what we see in California. We're currently around 14,500 vehicles in California. Drop in the bucket, but we expect that to grow as we hear the announcements and see new vehicles being announced, and those are the ones pictured below. So we do expect those numbers to keep growing. Next slide. In addition, we've also had hydrogen fuel cell transit buses in fleets operating in California for many years, and there are, I think if you progress this slide, there are a number of transit agencies there's a list of transit agencies who are planning hydrogen fuel cell buses for their fleets. And there's a lot of great data in that. Next slide. As well as heavy duty trucks. So the list to the right of the slide are all of the heavy duty truck manufacturers that are working in the hydrogen and fuel cell space. And of course, we have many more heavy duty applications, such as the switch locomotive we're talking about today, mining, marine, pretty much anything you can think of, hydrogen can have an application in. Next slide. And in California, we have led the way in emissions reduction and overall, air quality and so forth. And so in meeting those targets and getting to our 100% zero emissions, next slide, we do need to have both hydrogen fuel cell and battery technology. And this is really key and is something that our partners at the state agencies also recognize. And in fact, if you go to the next slide, we do have a light duty hydrogen fueling market. It is a nascent market, and we are working to that 200 station goal. The Fuel Cell Partnership did publish a document in 2018 with a target or a milestone of 1,000 stations to support upwards of 1 million light duty fuel cell vehicles, which we still want to see. But we are working toward that 200 station goal currently. Next slide. And in that, our partners at the state, again, have published a self-sufficiency study, which reports that with, relatively a small amount of funding, more funding, that we can reach a point where we are self-sustainable and the market takes over. And that's another thing that our vision document that was on the previous slide points out as well, as sort of, where the market takes over and what we need to get there. So both documents can be found on our website. And more recently, we published a fuel cell truck vision document, which puts out another milestone or something to meet with 200 stations for 70,000 trucks, but realizing those trucks, as well as trains, don't stop at the California border necessarily. The switch locomotive, of course, is local, but if we're talking about rail applications across the board, those don't stop. And so with this heavy duty truck vision, we started thinking more about moving outside the borders of California, and we are working on a mobility plan. And next slide, which leads into the work we're doing with the ARCHES Consortium, which is the California Consortium for putting together the California submission for the DOE Hydrogen Hubs submission, and connecting those, our mobility plan would work towards connecting those hubs and really bringing together and uniting around the country based on, heavy duty and filling in with the light duty. So just a kind of quick big picture of all of the activity that's happening in hydrogen. As Bart mentioned, there's so much happening right now and we're really excited. So let me move on quickly to the next set of slides, and we'll talk a bit about the properties of hydrogen and some kind of high level safety. I realize I'm moving quickly. There's a lot of information to share, which is on these slides, and of course, happy to answer any questions. Next slide. So hydrogen has been around, as you saw from Bart's slide too, for a lot of years. It's been used in industrial processes for many decades with a pretty good safety record. There's diverse sources of hydrogen as well as diverse applications. As you saw just within transportation, there's a wide variety, but there's also stationary, backup power, all kinds of things. And so suffice it to say, there's many ways to make and use hydrogen. Of course, getting towards that carbon-free pathway is what everybody is headed towards. Next slide. So why are we using hydrogen as a fuel? So again, hydrogen's been around, it's been used for a long time. What's relatively new is putting it into these vehicles and using it in the transportation sector. So it is an energy carrier, and it is zero emission at the point of use. And we'll see in a moment how a fuel cell works. But there are, some advantages to using hydrogen in the transportation sector, and getting that zero emission and low carbon, meeting those goals that we need to. Okay, next slide. Just a quick list of some of the ways hydrogen has been used historically. Again, what's new is putting it into the vehicles. Actually, one of the biggest uses of hydrogen is in refining the fuel that we use currently. Next slide. And because hydrogen's been around for a long time, it's also been transported. So we do have an established transport and distribution system, although that is growing, and there's a lot of study going into more production and distribution of hydrogen. So these are examples of transporting gaseous hydrogen, which are in pressurized gas tubes on a trailer. And these are, there's the sort of standard industry ones, and then there's some newer designs that have come out more recently. It can also be transported, next slide, as a liquid. It can also be stored as both a gas or a liquid at the point of use at the station. So when hydrogen is liquefied, it is a cryogen, meaning that it must be at those very cold temperatures to be liquid. And again, this is common industrial practice. It's been done for decades. Next slide. And part of my job with the Fuel Cell Partnership historically has been doing outreach and education for our first responder community. And so we'd like to point out that because hydrogen is an industrial commodity, it has been used for many, many years. That, of course, is included in a standard book that gets reissued every few years from the Department of Transportation. That's the Emergency Response Guide. So this is the placarding that one would find on those transport trailers for both liquid and gaseous hydrogen. Next slide. Hydrogen does exist as a gas at ambient conditions, and it is very light. It's 14 times lighter than air. Again, for it to be liquid, it does have to be brought to those very cold temperatures. And when we talk about dispensing and selling hydrogen for vehicles, we refer to it by the kilogram, but you can think of hydrogen, a kilogram of hydrogen, sort of like a gallon of gasoline, because if you were to burn, we're not burning, but if you were to burn a gallon of gasoline and a kilogram of hydrogen, you get about the same energy output from that. So we can speak about those sort of interchangeably. Next slide. Again, hydrogen is very much lighter than air. It's 14 times lighter, which is a bit of an advantage. We don't want it to leak. We want it to keep it where it belongs, but if it does leak, its tendency is to rise and dissipate. It's also colorless, odorless, and non-toxic. So we do have other methods of detecting hydrogen should there be a leak. And we also have methods of detecting at very, very low levels so that we don't get, mitigate getting into a potentially dangerous situation. Hydrogen's a fuel, and like other fuels, it has certain properties that we need to understand and design systems so that we can use the fuel safely. Next slide. So we do have safety systems at the existing fueling stations. We have around, I think 53 retail stations right now that are operating in California, with 3 heavy duty stations for the heavy duty trucks, and all of them will have these safety systems, such as everything around the pressure, the high pressure storage, as well as fire and leak detection. Next slide. Of course, these designs do go through safety and risk analysis and are cited and installed according to current fire code and NFPA 2, which is the Hydrogen Technologies Code, which, by the way, California does adopt by reference into the California Fire Code. And then there's the systems that you see at just your everyday regular gasoline fueling stations, such as e-stops and breakaway on the hose. Next slide. There's not one way to do a station, although some companies are sort of settling into one design for their company, but there can be delivered hydrogen to the station supplied as a liquid or as gaseous hydrogen, as you saw in those 2 slides of the delivery trailers. Or we do have a station in California that is off of an existing refinery pipeline. So there is some existing pipeline, and you could also make hydrogen on site, but so there's a little bit of a variety in how a station can be designed. Next slide. And of course, there are the applicable safety codes and standards that go into the design and installation of the station, as I mentioned, NFPA 2 for installation, things like fuel quality. We have a standardized fueling protocol for the light duty vehicles, and that's being worked on currently for heavy duty, which could be expanded to the other heavy duty applications, as well as the various component standards around the station equipment and the vehicles. Next slide. This is a schematic of a light duty vehicle fueling. So the dispenser is similar to what you would see, and that's so far not deviated from what I've seen for the other applications. Things that might differ are, the hardware in the fueling nozzle and the connector, the size of the storage cylinders on board a vehicle, but likely going to have a lot of similar components. And in talking, for example, about, next slide, the on-vehicle storage, these are cylinders that are designed and manufactured and tested to existing safety standards. And they do go through testing and receive a lifetime approval, which is usually in the 15 to 20 year range currently. And that's very rigorous testing. I sit on the codes and standards committees that develop these, and I can attest to the amount of thought and engineering and resource that go into these codes and standards. Next slide. So quickly, what is the vehicle doing, regardless of what it is, with the hydrogen that gets put on board? It is using the hydrogen from those storage cylinders in a fuel cell stack. This is an example of a single fuel cell, which is composed of a positive and a negative electrode. And there is a membrane in between those two electrodes that will catalyze the separation of the hydrogen molecule into protons and electrons. And the electrons are what generate the electrical current that power the vehicle, and excess current gets put into the battery. The outcome of that reaction, that electrochemical reaction, is the oxygen from the air that's used in the reaction, the hydrogen that's used from the onboard storage cylinders come back together on the other side, forming water as the byproduct. So again, zero emissions out the tailpipe. So that's a quick and dirty. Again, I'm open to questions. There's more information on these slides than I covered, but I want to give you some resources. Of course, our website, h2fcp.org, there's our station map, FAQs. You can see by the numbers where we are with vehicles and stations in California. And then the Center for Hydrogen Safety, of which we're a strategic partner, houses the hydrogen tools resource, as well as resources for first responders and others, lessons learned, best practices, and so forth. And I think that's all I have for you. Thank you.
Thank you, Jennifer. Really appreciate that comprehensive overview. I know that there were a lot of slides there and a lot of information that we can glean after with the slide deck. So really, thank you for that. And next, I have up the University of Riverside, George Karavalikis, if you are able to unmute.
Yes, thank you, Grace.
Yeah.
All right, thank you. Good morning, everyone, and thank you for the opportunity to be here. As Grace said, I represent the University of California, Riverside, and the Center for Environmental Research and Technology. First of all, let me thank my co-authors, Dr. Ken Johnson, who is the PI of this program, and Peng, as well as Grace, our graduate student. Just a brief introduction about us, about CSERT. CSERT is the largest research center at UC Riverside that brings together multiple disciplines throughout campus to address society's most pressing environmental challenges in air, energy, and transportation. We have pioneered research on the impacts of low carbon fuels and zero carbon fuels, air quality and health effects, emissions characterization, technology demonstration, and onboard emissions and performance measurement for a variety of sources, from small engines to large generators, from light-duty vehicles to heavy-duty trucks, for locomotives and marine vessels. Today, I have a very short presentation to describe our role in this exciting project. It's pretty short because we haven't got data yet to basically start our work. So UCR's role will be to perform a life cycle or LCA assessment for a hydrogen fuel cell switcher train. It is expected that this type of analysis will be more broadly applied for this type of locomotives in California. Life cycle assessment is a cradle-to-grave or cradle-to-cradle analysis technique to assess environmental impacts associated with all the stages of a product's life, which is from raw material extraction through materials processing, manufacture, distribution, and end use. In our case, we will exercise the well-to-wheels analysis that is used to assess the LCA of fuels, including all phases of their life cycle, from extraction of raw materials to their use. This analysis will allow us to better understand the impact of fuel cell locomotives in terms of their greenhouse gas emissions, such as CO2, methane, and N2O. There are two components to the well-to-wheels assessment. The first is well-to-tank, and the second, tank-to-wheels analysis. Well-to-tank includes the fuel production phases, and tank-to-wheels, the use of fuel. Now, these terms matter and are a hot button topic for those who struggle to determine whether the environmental impact of greenhouse gas emissions of different power sources should be measured with the well-to-wheels process or only a part of it. Next slide, please. So since this is a California-centric project, we will implement the California greenhouse gases, regulated emissions, and energy use in transportation, or GRID model. The GRID model that was developed many years ago by Argonne National Lab is a tool that examines the life cycle impacts of vehicle technologies, fuels, other type of products, and energy systems, and it's widely used across the US. Essentially, for any given energy and vehicle system, GRID can calculate total energy consumption, emissions of air pollutants, greenhouse gases, and water consumption. So we will be using the California GRID version 3.0 model, which is the latest version, and was released in 2018, and is used to generate the carbon intensities of all different fuel pathways. For the purpose of this work, the well-to-tank analysis will be focusing on the hydrogen production methods and distribution, while the tank-to-wheels analysis will be using locomotive activity data that will be collected by UCR, such as data related to the locomotive operation and mileage traveled, etc. Next, please. Now, this slide shows an aerial map of Sacramento with the green dots showing the trace of the baseline diesel locomotive. These traces or route will provide the activity data that will be collected by UCR to be used in the life cycle analysis for the comparison between the baseline diesel locomotive and the modified locomotive powered with a fuel cell system. And last slide, please. This, I think I have one more.
That might be all the slides that we have.
Oh, okay. I had one more, but it's fine. It's fine. Thank you so much.
Thank you. All right, well now I will head over and talk about the public health impacts and improvements of hydrogen. So you all heard the various applications for hydrogen, and excited to share more about the public health improvements that are going to be happening as a result of this project. So what is diesel exhaust? So diesel exhaust is made up of particulate matter and various gases, and actually includes over 40 substances that are listed by the US EPA as harmful and hazardous air pollutants. And so we're excited that this project will be replacing 10,000 gallons of fuel that are used each year to run this switcher locomotive. And as you all have seen this map multiple times now, this is the existing route of the switcher locomotive. So it'll be really great to for the air quality improvements and also the noise and odor improvements in the neighborhood. As part of Valley Vision's role, we did community engagement in this neighborhood and went door to door to let all the folks know the good news, that the train that's behind their house is now going to be much cleaner and quieter for them. So they were all very excited. Didn't hear any negative feedback there. So again, the impact to the surrounding community will be an immediate improvement to the air quality, reduction of greenhouse gases, noise, odor, and then a long-term reduction of ozone levels that are again generated by that diesel exhaust. So the potential market for switcher locomotives in California includes more than 260 switchers, and Sierra Northern Railway wants to convert their entire fleet to zero-emission hydrogen. So we're very excited about that, and I wanted to be short and sweet so that we would have enough time for Q&A, because I know we have several questions. So I thank you all, and I invite the rest of our panelists to come on up to answer some of the questions that we have. And here's the contact information for Bart, Michael, and myself if you'd like to get in contact with us about the project. So now we'd like to move to Q&A, and one of the first questions that I have is for Sierra Northern Railway. So Ken, if you're able to answer this one, so we had said earlier that the goal is for the entire fleet to be converted to zero-emission hydrogen. How many locomotives is that for Sierra Northern Railway? What is the impact there?
We have well over 40 locomotives in our fleet right now, spread throughout California. The goal is to convert all of them. While we're working on hydrogen locomotive number 1, our plan is to continue to build and commercialize them.
Great, thank you. And there was a question I believe it's for you, Jennifer, is that you mentioned that 1 kilogram of hydrogen is energy equivalent to 1 gram of gasoline, and in light duty vehicles, what volume of space does 1 kilogram occupy compared to one gallon of gasoline, not 1 gram, 1 gallon of gasoline?
I was just typing up an answer. So the hydrogen needs to be pressurized because a kilogram of hydrogen in the atmosphere takes up far too much space. So the hydrogen is pressurized and stored in high pressure cylinders on the vehicle, and the total storage capacity of a vehicle, depending on which car we're talking about or which vehicle, for the light duty is somewhere in the 5 kilogram plus or minus range. And so that in energy is equivalent to about 5 gallons of gasoline, but you get the comparable range you do with a gasoline vehicle because the fuel cells are very efficient in how they use the hydrogen.
So if I could add to that, Jennifer, so, I'm sorry, go ahead.
I was just going to say, if you saw the images of those vehicles, they look just like your normal gasoline vehicle. So the storage system is inside the vehicle, and it looks like any other. So it's they've got that where it doesn't take up really any more room than a gasoline tank.
Yeah, it's about so at 10,000 psi, which is what we see in the light duty vehicles, those 5 kilograms of hydrogen will take about 35 gallons of volume.
Great. And then there's a question about if the hydrogen will be developed on site or delivered to the port, and that could this be a good location for a hydrogen hub? I don't know who wants to answer.
I can answer that. So the hydrogen will be delivered to the port. Since this is a pilot or first of its kind demonstration, it really is hard to justify the investment in building a dedicated station or production on site. So the hydrogen will be delivered. But the second question, that's a great question. All of the ports are great locations for hydrogen hubs, whether it's seaports, inland waterways, or airports, because they combine multimodal consumers of energy. You have planes, trains, automobiles, trucks, and ships, and forklifts and cranes, and they all use energy. So the more energy consumers you have in single location, the better the chance for that hub to be successful.
Yeah, and in Arches, one of the current working groups is specific to ports, and there absolutely has been, discussion and including the inland ports in those efforts. So that's ongoing work, but the short answer is yes, maybe not directly as a hub itself, but I'm sure as included in the work we're doing on the hubs.
Great, thank you. And the next question is, what is the biggest impediment to building the hydrogen locomotive? And what can CARB, CEC, and the Department of Energy and others do to help convert all of the switching locomotives?
Bart, I'll jump in on this one. The biggest impediment right now certainly is cost. A switch locomotive, an old switch locomotive, can be purchased for $150,000. Tier 3 was, in its day 10 years ago, was purchased for about 1.5, 1.6 million. A Tier 4, the latest and greatest, is pushing 4 million. And we're going to have 6+ million, maybe closer to 7 million invested in this hydrogen locomotive number one. So money is number one. So when it comes to CARB or anybody else, funding, certainly grant funding to convert these railroads. Short line railroads work on a very slim margin. It's a very capital intensive business. We don't have a lot of free cash to spend on $5 or $6 million locomotives each, and especially in my case where I've got 40+ of them. That's quite a hill to overcome. So we are talking to CARB, we are talking to the federal government. There are some grant applications being put in, but it is a long uphill battle. And then the only other current impediment is supply chain is certainly an issue right now. Everybody's chasing the same thing with batteries, with hydrogen fuel cells and everything else. So it is a challenge all the way around.
Well, that relates to one of the other questions, is that what is Sierra Northern Railway expecting to spend on fuel, and will the cost be comparable to diesel, or are you knowingly taking on higher costs?
I don't know the dollar figure right now. I do know that the hydrogen current market is considerably higher than diesel. So we are taking on that extra cost. I circle back a little bit because to answer another question, we hope hydrogen is going to come down. And I'd be remiss if I didn't mention our sister company, Sierra Energy, who is working with their FASTOC system to create clean carbon negative hydrogen. So in the long run, that's our plan, is to be able to create our own hydrogen via our sister company's process on location, and hopefully at a less cost than diesel going forward.
Thank you. And I know yesterday CARB approved of the scoping plan, which is really going to decarbonize a lot of industries and sectors. And just wondering, how quickly could Sierra Northern Railway convert their fleet if funding were available?
It's going to be quite a few years before we can convert 40 locomotives. Once we prove out the first one, get the second and third going, we hope to build multiple units a year. But even if we build 5 or 10 a year, we're 5 to 10 years out to convert the entire fleet. And that's just our fleet. That doesn't address the other 270 switcher locomotives in the state of California.
Great, thank you. And will the Sierra commercial and sell to other short lines in California and nationally after you have finished building, this switcher and others throughout California?
Yes, our hope is to commercialize this. So not only build for ourselves, but build for our short line partners within the state and across the country. That may slow down the conversion of all of ours because we'd like to start hitting everybody's needs. And so we may build one for us and multiples for other people. That we're working on that right now. And Michael Faust would be the point man on any further discussions on that.
Great, thank you. And this one is for Jennifer. So, there are some concerns that folks have with hydrogen, and it's a fuel that we've been using for many decades, but there's still some overall concern that people may have of this larger vehicle coming into their community. Do you have anything to address that, or any safety measures that are in place that you're aware of?
Oh, as far as any potential incidents, is that?
Yes.
I guess we can ask the person asking the question. So I know that this project is, of course, working with Federal Rail Association on the rail requirements for this. And in terms of the components, I mentioned the cylinder construction and the testing that those go through. And there's also, all of the known hydrogen components from the suppliers for the fuel cell and the associated piping and things like that, and all of the safety systems. And I can say that this project is utilizing the resource of the hydrogen safety panel and an excellent third party in the risk evaluation and really looking at the system and identifying potential risks and then mitigating those. So there's a great team on that, and there's a lot of resource going into that. Absolutely.
Thank you. And the next question that we have is, how will the locomotive be fueled now that the Shell station won't be built?
I can answer that. So we will be bringing hydrogen to the site. We'll perform what's called wet hosing of the locomotive, similarly to what you see typically in the industry right now, where this type of heavy equipment very often is fueled from a mobile fueling truck. Rather than just having a pump and a dispenser, you just bring fuel. And we see that all over, whether it's rail or cargo handling, so cranes, forklifts, and yard tractors. Or you see it even in the construction with the construction equipment such as excavators and bulldozers, right? The fuel is being brought to the equipment. So we'll just do the same. We'll have the hydrogen brought in and fuel the locomotive approximately once a week, because that's how we designed and sized the components on it.
And then as a follow-up to that, Bart, what kind of energy is used to produce the hydrogen currently?
Well, so we're not producing hydrogen under this project, right? So maybe I'll treat it as a general question. And hydrogen is produced through a variety of different processes. And it's hard to answer that question with a single answer. I know in the past, there has been a concept of hydrogen colors, which I strongly advocate for kind of getting away because it's misleading a little bit. We should be talking about hydrogen or any energy in terms of carbon intensity. And hydrogen can be produced with carbon intensities varying from negative to 120 grams per megajoule, which you can compare it to electricity, you can compare it to diesel or any other source of energy or carrier of energy. We will be making decisions on procuring our hydrogen. We will know more what is our carbon intensity when we're ready to start fueling the locomotive.
And if I could just add, I think an important thing to remember is the emissions that are being cut by using hydrogen in this application for this particular vehicle. Regardless of the source, there's still a reduction overall in emissions. So
absolutely, there's no tailpipe on the locomotive. There's
right.
no emissions, just like a Tesla.
Thanks, Bart. And then one question that we have is why hydrogen but not electric? Is there a cost for hydrogen that makes it more affordable or efficient compared to electric in the future? Ken, I don't know if you can take that on.
I'll just say hydrogen fuel cell vehicles are electric. They just produce their electricity in real time on board the vehicle. So I think the question is all battery versus hydrogen fuel cell. And I'll let someone else take that on.
And certainly, thank you, Jennifer. It should be known that all locomotives currently operating are considered diesel electric. The diesel motor creates electricity, but the axles are driven by electric motors. So what we're doing is finding a different way to create electricity to move the locomotive. So it could be diesel, it could be hydrogen, or it could be batteries. The reason we're doing hydrogen versus batteries is purely about energy density. You can't get enough batteries on board a small switcher locomotive to do the work and replace the work that a diesel fuel tank can do. The hydrogen fuel cells, the hydrogen tanks, and we will have batteries, so it is a hybrid, will do the replacement work of diesel that pure battery locomotive won't. There are other folks out there doing work in the full battery, but it's not proving to be as efficient right now as the hydrogen is.
Great. Does anyone else want to answer that question? If not, Ken, I have another question for you about the supplier. It's asking if you increase the FC locomotive, is the supplier only Ballard? Are you thinking about others to join?
Right now, our partner on the fuel cells is Ballard. What that means going forward, I don't think we can say. We're definitely happy with Ballard. They've been a great partner. And if they're able to continue to supply the number of fuel cells we need in a good time frame, they're certainly a player. But there are other folks out there in the fuel cell world, and as you can imagine, they're knocking on our door on a regular basis. So we're not saying no to anybody, but we're currently working with Ballard on this project.
Great. Well, I want to be mindful of time, and I know we're right up at time here, so I want to thank all of our panelists for all of the questions that you answered in your presentations, and for all of the attendees for sticking with us through this hour. We really appreciate your engagement and all the great questions that you asked. And again, this presentation slide deck and the recording will be available on Valley Vision's website, and we'll send a follow-up email in the new year with all of that information. So thank you all for your attendance.
Thank you.